So I want to go through the homework problems to try to explain a little bit about what to do, just to make sure that everyone's on the same page. Problem 1, you'll notice, consists of a lot of tabs because we're generating samples of different sizes. So the first tab is the population data, and all I want you to do here is I want you to compute the mean and the standard deviation for the original data. Okay, so all of the, 433 values. Okay, I want you to compute the mean and the standard deviation. And then I'd like you to make a histogram. So, using the max and the min. In fact, I can put these on here. You'll use the max, the minimum. You'll use the range, and then figure out your bin size. So first, I'm going to divide the range by 6, and from that, I'm going to determine the bin size. I want you to make a histogram. And let me just take you through this really quickly, okay? I'm going to go ahead. I'm going to choose these values, and I'm going to order them. It makes it just a little easier. Okay, so what I'm doing now is I want to find the max and the min to create the histogram. So I've selected all of the data values. I'm going to go to Data and click Sort. Do not click Expand the selection. Basically, Excel is saying, hey, I see other stuff over here. Do you want me to sort all of that? And we don't. So we're just going to say Continue with Current Selection. And we're going to go from smallest to largest. You can do whatever you want. Usually smallest to largest is just kind of natural. That's how we order things, right? And so the minimum I can see is 56. I pick that off. And if I go to the bottom, I'll get the maximum, which is 70.5. Okay. You don't have to sort. You can use the commands max and min. You'll get the same result. And so, of course, the range is equal to the maximum minus the minimum. And the largest bin size that I can have is going to be the range divided by 6. So I'm going to take this value for the range, divide it by 6. This is the largest the bin size can be. And notice it's an ugly bin size. It's not a nice number. I'm going to round that down to 2. So I'm going to use a bin size of 2. And so I'm going to start at the minimum value, and I'm just going to keep adding 2. And so one way to do it is to say, take whatever's in the cell above, add 2, and then just drag that down until I get to 72, right? Okay. And now you're ready to make the histogram. And I'm going to put the histogram over here. Let's put the histogram in columns K and L, okay? Okay. And then you'll make your histogram plot. So that's what you'll do for the first page. That's pretty straightforward, okay? And I'm gonna erase all this because I want you to do it. And I want to see the commands. Don't just type in the numbers, okay? But I'm just showing you how to do it. You know what? I'll leave it on. It's not a big deal. I'll leave it on. Okay. I'm going to do things a little bit differently than what we did yesterday. What I'm going to do is we're going to actually choose a sample size of 1. Okay, we didn't do this yesterday. We took n equal to 1 be the whole population. But let's just choose sample sizes of 1. I'm going to choose 20 sample sizes of size 1. I don't know why it skipped. I got to delete that, sorry. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that looks okay now. All right. So what we're going to do is we're going to just generate a random sample. We're going to reach in the bag and just choose 1, okay? And I'm going to start here. This is going to be the first sample. So this is the sample number, not the number of items in the sample. This is a sample number. So I'm choosing 20 samples here of size 1. Okay, so I'm going to go here, and we'll go to Data, Data Analysis. I'm not quite sure what's going on there. There we go. Okay, and then I'm going to go down to sampling. My input range is always the same. This time I'm not going to select the label, okay? If you selected height of females, you have to click this, but let's not do that. Let's just do this. Okay, I selected all of the data values that I want to sample from. All right. It's going to be random, and I'm only going to choose one sample. And that seems kind of weird, but I'm going to do this to compare to the other sample sizes. And the output range, and again, be careful when you click here, because what will happen, instead of going to the box the way it should, it'll go up to the input range. See? For some reason, that's the default. But I'm just going to click, make sure I have the right one. I'm going to click there. Okay? And all I'm going to do, because I want to make life easy on myself, I'm just going to repeat this and change the letters. So when I do data analysis, I repeat the same thing. And all I do, I keep everything else the same. I'm just going to change where I wanted to put the new sample. And I'm just going to keep doing that, okay? I'm going to go over. And by the way, you can use the arrow commands. The arrow commands will move you sideways. So I just hit the right arrow key. It makes it easier. Sampling, J, okay? And if you didn't want to be that slow, and some people don't, you could just generate a whole random sample of size 20 and cut them out and put them in each cell. But I'm not going to do that. Okay, data analysis. You know, whatever is faster for you. Whatever the last letter is, you just increase it to the next one, right? Over key, data analysis, sampling, L. Okay? Go over. And you're going to keep doing that. Okay? And maybe I'll finish out, maybe I'll finish out this one for you. Okay, I'll just finish this out real quick. Over key, data analysis, sampling, and okay. And you just keep doing this. It goes over some ways. Okay. Anyhow, I'm going to let you finish this out, okay? What's going to happen is, here the average is just going to be the data value. Okay? So here the average is simply the data value. So when you get done, all you're going to do is, if you want to, you can say average, or you can just literally do this, and it will move it right down into that cell. Okay? Because the average of one value is just the value, right? So now I have 20 samples of size 1, and what you're going to do once you do that, and I'm going to pretend that I have a smaller sample size here. All you're going to do is you're going to copy this and paste this in the row below. Notice I have X bar copy. And there's a reason why. It's because when you cut and paste this, so I'm going to go ahead and copy this, just to show you how I do this. And then I'm going to paste it here. But I'm going to paste it as values. This is important. You can do this a number of different ways. You can do this here. And notice that it actually says paste values. I'm going to paste this as values. I need to paste it as values because I can't make the column to make the histogram from if I don't paste it as values. So I'm going to generate these random samples of size 1. I'm just going to drag this down and repeat this, and then I'm going to copy it down here. Okay, why am I going to do that? Because now I'm going to copy this row. I don't know why it's saying that. Let me try one more time. Here we go. And I'm going to paste it here, but again, we're going to use that transpose, okay? So now when I paste it, I'm going to paste it as a column. Okay? Now I can do the max, and I'm going to finish this out. So you're going to finish out this row, finish out this column, and then you can figure out the max, the min, the range, and let me write it as range divided by 6 here. This will be the maximum bin size, and then you'll figure out your bin size right here. Just drag this down. And then you can make your bins and make your histogram. Okay. Two other things you want to compute is you want to compute the average of the X bar values in column B. So I'm going to take the average, this is one other thing I'm going to need, of the X bar values in column B. And I'm also going to take the standard deviation of those values. We can just put those here. So I want the average of those sample means, and I want the standard deviation of those sample means. Okay, that's all you need to do. Now you're going to repeat this. You're going to do this for size 4. Do the same thing. So you're going to generate 20. I don't know why that kept skipping. I'm going to generate 20 samples. Each sample is going to have size 4. I'm going to compute X bar for each sample. Then I'm going to copy this down here, and I'm going to paste it and rotate it here, and then do my bins by doing the max, min, the range size, and it's always handy to put this here. Just okay, and then the bin size, and then finally we also want to put the average and the standard deviation. Okay. Actually, let me go back for a second. Okay, let's see if this worked. Almost. Okay, so you're basically doing the same thing, right? Except now you're just generating 20 samples of size 4, but you're computing the average for each of those samples, and then you're copying it here as values. I'm going to put as values just so you remember. And then once you do that, that allows you to copy and paste it by rotating it as a column. Then you take the max, the min, the range, largest bin size, and then you can make your bins and your histogram. And then you'll also want to compute the average and the standard deviation too. Okay. And so you keep doing that. You're going to do that for n equal to 9. And I'm going to let you make the column for n equal to 16. I'm going to let you fill that out. Okay? So that's what you're going to do there. Now, once you get the results, that's going to take a little bit of time, but that's okay. Now, once you get the results, you're going to go to the Word document, and what you're going to do is you're going to take the averages and the standard deviations that you computed in each of those sheets and either cut and paste or type them in here. Okay, so in other words, for n equal to 4, right, I'm going to have an average and a standard deviation, and so I'm going to put the average and the standard deviation here. I'm just going to fill out this table based on what I got from my Excel file. And I'm also going to take the histogram. So here are four places here. You're going to take each histogram and just paste it in here. So for n equal to 1, n equal to 4, n equal to 9, n equal to 16. And I want you to comment on what you see. So comment on the shape of the histograms. And their similarities and differences. Oops. Okay, now finally, if you want to do extra credit, here is kind of a fun little thing to do. We made a claim, the central limit theorem made a claim that the two things are true. It claimed that these averages should be equal to the population average. Okay? Now it's not going to be exactly true because we only took 20 samples, but the claim is that if I took more than 20 samples, suppose I took 2,000 samples for each of these, okay, and computed the average of those 2,000 sample averages, this would equal the population mean. In other words, it would equal whatever this value was right here. And the second claim is that the standard deviation here would be equal to the standard deviation of the population divided by the square root of n. And so we're gonna test this. If you want to do for extra credit, what you can do for each of these sample sizes, you can copy over the standard deviations that you got in the first table. Okay, so all you're going to do is you're just going to copy these standard deviations. In fact, you can actually do, this is the cool thing about Excel, you can actually copy this. You don't have to even type it. You can go right into Excel and you can say paste. You have to be a little careful. Watch, I think keep source formatting is what you want. And you can see it'll paste whatever's in there. Okay. And now you're going to make a second calculation. So here you're going to take the standard deviation from here. Okay? And you're going to divide it by the square root of n. So let me show you real quick. I happen to know what the number is, but okay. What I'm going to do is I'm going to say, okay, this standard deviation should be equal to this divided by the square root of n, which is here. Okay. And of course, this has a sample size of 1, so the square root of 1 is 1. That doesn't change. But what's going to happen is this is going to decrease. And the reason why it didn't was I didn't anchor the first value, right? I apologize. I have to anchor this value because I don't want it to move. I wanted to use it in every computation. So let me anchor that. Okay. And now we're good to go. Now when I pull this down, you should see the standard deviations are decreasing. That's how I knew it was wrong, by the way. Okay. Now I want to make a plot of this. So this is a little tricky. This part isn't too hard so far, right? Let me show you how to put two plots on the same graph. So I'm going to highlight this. I'm going to pretend like I don't want to plot this first. Remember, whenever I want to plot, oh, and let me, I'm just going to make up values, okay? Because I haven't done all this work to make this table yet. So let me just do something like this. And 0.48. Let's just suppose these are the numbers I get. So from n equal to 1, okay, this was the number here. I got it from the table also, right? Okay? And so I want to plot this first. I'm going to plot the observed standard deviation for the sample means versus the sample size. So I'm going to highlight them first. Of course, I'm going to go to Insert, and I'm going to make a scatter plot. Okay? Now, I want to add the second. So what I do is I click on this graph and I say select data. So let me show you again. It's a little tricky. I'm going to click on the graph. I'm going to right click and I'm going to say select data. And now Excel knows, he wants some more data here. So I'm going to click add. And I'm going to call this series, I'm going to call this theoretical, because these are the theoretical predicted values. Okay. Whoops. My X values are here. I think I want the label, if I'm not mistaken. You know what? Let me try it this way. I think it'll work with the labels. I'm not sure off the top of my head. And I'm going to plot this. And then I'm just going to say OK. And so I can change this name. I'm going to call this observed. Let me see. You don't have to change this one, but I am. Okay. And I'm going to go ahead and I think I can just say OK. And it plots them both. See? Like this. Something's wrong with this one plot. Some of these look the same and some of these this looks wrong. The second one looks wrong. Let me check it one more time, see what I did. Let me go back. Click on this. let's see, select data. I think this time I'm not gonna, I'm gonna call this theoretical still. I think this time I'm not gonna put in I think what happened was I put in the label and I shouldn't have. So these are my X values. These are my Y values. And I'm going to say OK, and OK again. And here, now it worked, OK? So don't put in the labels. What do you see? Well, you see that, and of course I made these up, but they'll be pretty close. But you can see that the theoretical and the observed are pretty close. So this standard deviation really is going down like the standard deviation of x divided by the square root of n. And then you can just go ahead and you can cut and paste. You can click on the border here for a histogram. And I'm just going to say copy. OK? And I'm going to go back to this part here and just click on this, and all you have to say is paste. Right click, paste. Usually it's a good thing when you paste to try different sorts, so it looks like it doesn't matter a great deal. And now you're going to comment on whether or not the central limit theorem is true. And what you're going to comment on is the fact that, well, the standard deviations decrease the way that they're supposed to, basically. Okay. These two plots, they should be similar, and the standard deviation for the observed should be decreasing like the theoretical. If you want this to look a little nicer, let me give you a little hint here. Type in observed. Okay. And then notice it will change here. Okay. You can put in a title if you want to learn how to do these things correctly. If you're in business, you should. You can put in a title. Let me just show you very briefly. I can put in a chart title above the chart, so I can put comparison of observed versus theoretical standard deviations for x bar if I wanted to. I can put in a label for the x under axis titles, primary horizontal. And I can just type in sample size. You don't have to even click in there. It automatically knows where you want to put it. And it should say size. I'm going to add size. Okay. And then you can put in a y-axis, primary vertical, usually rotated's good. And I'm going to put standard deviation of sample mean. You could say x bar. Okay, and now it looks really nice. Okay, you have a legend, you have labeled x and y axes. You can put a title in here and then paste that. And if you do that, I'll give you extra credit. That's actually, I think that's a decent amount of work, but it's really useful to know. I think Excel, these sorts of things about Excel really make it worthwhile. Okay, that's pretty much all you have to know for the homework. Oh, I should expand on the other problem. Sorry. For problem 2, you're just going to answer these questions, okay? You're told information about a bunch of tennis balls. You're gonna tell me the sampling distribution. Be careful. There's 3 parts to the sampling distribution, not just one. And then you're going to compute some percentiles here, right? Okay. The probability that you're between 2 values. And this is just like the problems that we did on the last homework set, right? I mean, x bar has a normal distribution, but we've worked problems with normal distribution before, so this is not anything particularly new, right? For problem 3, this is a little different. Here you're given a word problem, and you're asked if it's a claim, if you're testing a claim or a belief about the population mean, or if you're seeing if the population mean changed after some sort of change occurred. If there's a difference in the population mean after a change occurred. And so here, these look kind of long, but really, you're either computing percentiles or you're computing data values corresponding to certain percentiles. So the thing to do in problems 3 and 4, the smart thing to do is to write down the information the way we did in class. Remember, what is mu? What is sigma? What is the sample size? What is x bar? And does x bar have a normal distribution? So these are the 5 things you need So here you want, you want to know what is mu for all of these problems. What is sigma from the population of the population? Okay. What is the sample size? What is x bar in this problem? And does x bar have a normal distribution? And remember how we... Okay. And once you can answer these 5 things, then you're ready to start the problem. But these are the 5 pieces of information that you always have to know for any sort of word problem, okay? Then you're ready to start. Okay. And 4 is the same way. It's actually using the same situation, but we're looking at the problem from a different perspective. Okay, that's all for the homework problems.